Okay, we're going to go over trigonometry and we're going to focus on this ambiguous case. We should talk about the ambiguous case. Sorry. Let's go over the example. They've given us two side lengths of a triangle and an angle within this triangle. So we'll do our best to kind of make this. It won't quite be to scale, but we got a longer side. This looks like a bit of a shorter side, and then it kind of goes to here. So if I were to call this side A, it would be 26 units. We'll say they're inches. Okay. This side, call this side C. We'll call it, and I'll say that's 34 inches, which then makes this angle, which is, I guess that's somewhat realistic, 78 degrees. Okay, so they've given us this information. And this C could have been here or here. Just because of the way I drew it, this side looked longer than this, so I drew it that way. But to be the ambiguous case, okay, so this is a non-right angle triangle, or at least we're assuming it is. We don't know that it is. There's a possibility this is 90 degrees, but we don't know that for sure. So what we're going to do is we're going to assume it's not, which means we use one of two laws. We either use Sine Law or we use our Caste law. Okay. Now, with those two laws, I'm going to draw a reference to the Cartesian plane, which is that a kind of T-chart you use for graphing. Okay. And there's something called the Caste System that goes along with it. And the Caste System will give us an idea of why we can have an ambiguous case. Okay, so we have C, A, S, T. Okay, and this is quadrant 4. I don't know why I started there. This is quadrant 1, 2, and 3. Okay, so from quadrant 1, that stands for A stands for all. So that means whether we're using sine, cos, or tan, which isn't quite in there, everything in this quadrant will have a positive ratio. Okay, which is fine because that's what we're used to working with. And that's from 0 to 90 degrees, which is most of the triangles we deal with. Okay, and then from quadrant 2, we're looking at 90 to 180 degrees. Okay, and in this quadrant, only sine is positive. Okay, only sine is positive, which means cos is negative and tan is negative. So if we're talking about a triangle in reality, we don't really ever have a negative triangle. What do we mean by that? Well, I'll quickly draw it out here. So I have cos theta some angle is equal to the adjacent over the hypotenuse, and tan theta is equal to opposite over adjacent. What it's saying is if we have an angle between 90 and 180 and we use either cos or tan, our ratio, so this part here, is going to be negative. And in order for this to be negative, that means either the adjacent side is negative or the hypotenuse is negative. And in reality, we don't have a negative measurement of something, right? We would just say the length of this side of a building is 10. You wouldn't say it's negative 10. So these two don't really make sense, okay? And with that being said, there is a tan law. They don't really teach it, okay? So if you wouldn't be able to use tan law in this quadrant, okay? And you wouldn't be able to use cos law because there's no such thing as a negative measurement again. So we don't use cos law in the second quadrant, but sine law can occur in either this quadrant or this quadrant, okay? Why not the next two? Well, we know a triangle can only add up, all the angles can only add up to 180 degrees. So with that being the case, the next quadrant would be 180 to 270. It's impossible to build a triangle and have an angle that's within here. Because if you have an angle in here, that one angle alone is larger than any triangle could ever be. So triangles can't exist in here. I know that's very theoretical what I showed you, but this is the reasoning to this. So cos law doesn't happen for our ambiguous case. Ambiguous case only happens with sine law. Okay, and we're going to talk about how the interpretation, we could have an angle in here, or it might be an obtuse angle along with it. So we kind of have to go about figuring this out. Okay, so when we do that, let's take these measurements again. We have these measurements here. I'm going to set up our sine law, put it in black here. We have sine of angle A over A is equal to sine of angle B over B, which is equal to sine of angle C over C. What measurements do we have? Well, we have side A is 26, angle A is 78. So I have sine 78 over 26. B, we don't know anything about side B or angle B. And angle C is unknown, so I leave it as C. But side C, we know it's 34 inches. Okay, so we have 34 inches here. Now, because this is a ratio of essentially 3 different things, this one we have no information about, so we can kind of just drop it off, and we'll just work with the 2 on the outside. They're technically equal each other. And this way we only have 1 variable to solve for. It's very hard to solve for more than 1 variable. There's a lot more complicated math involved. So we have sine 78 is equal to, or over 26 is equal to sine C over 34. So, excuse me, what we need to do is find out what this angle is. Okay, so we got to isolate for this. In order to isolate, I have equivalent ratios or equivalent fractions, so I can bring this over and multiply by 34 this side. Okay, and then to isolate for the C,
sine inverse.
Yes, exactly. So we can do this all in one step. C is equal to the sine inverse of 34 times sine 78 divided by 26. Okay, and whatever that is, C is equal to it. So we'll take a calculator and test it out here. Let's see if I can do it on this one here. I think I can get a pretty good one. Did the calculator show it? I don't know where that went. Let me find it. Hold on. Unfortunately, we have to use this native calculator. It's not so nice. I can't write it all out in a big long string here. So I'm going to do the sine 78 first. So I actually have to put 78 in first, and then I do the in. Oh, no, I don't want inverse of sine. I want sine of that. So that gives me a value, and then I'm going to multiply that by 34.
How many meters in a kilometer?
1,000.
Okay.
And then I'm going to divide this by 26. And we get 1.
You want me to write that down?
1.279. Well, there's a little issue here with this. Sine inverse of 1.279?
Yeah.
Okay. We have an issue here. So this, and you'll see in a second. Well, second, I do sine inverse of that. Not a number. So why isn't this a number? Well, this is not a number because what we have here, if I brought sine back over, I'm going to bring it back over. 1.279 is equal to sine of C. Well, we know that sine is equal to the opposite over the hypotenuse. Okay, sine C is equal to that. So this number here. In order for this to be true, the hypotenuse of any right angle triangle, okay, the hypotenuse has to be the longest side. And if that's the case, if it's the longest side, that means we have the bigger number on the bottom. Okay. And the
So it has to be a decimal.
Yeah, it has to be less than 1. Okay. So because of this, this is actually an impossible triangle. So I should really have renamed this. Okay. This is trigonometry and impossible triangles. Let's change this name here. So this is an impossible triangle, and you can find that out by essentially, if you're ever using cos or sine, whenever you're doing the inverse of it, you must be doing the inverse of a number less than 1. So this is impossible triangles. Okay, so we've renamed it, but an impossible triangle. But let's say we got a value of. Let's say we got sine inverse of 0.8 is actually the value of C. Okay, so we're going to have to disregard the numbers from above because they're not going to quite work for this. But this is where we can get this ambiguous case. So we do sine inverse of that. Bring up that calculator that I struggled with. We are not a number. 0.8. And we want the sine inverse of it. 53, approximately. So angle C is approximately 53 degrees. Well, what that means in terms of calculating the ambiguous case is we can now have we need to find 2 angles, okay, from quadrant 1 and from quadrant 2. So in quadrant 1, we already know the angle. We know the angle to be 53 degrees. Okay? In quadrant 2, it's 53 degrees away from 180. Okay? So it's actually this obtuse angle here. Okay, so I should maybe change the color of the original one. Say that this was in green, and it's 53. Okay. Okay. This one is 180 minus 53. So this angle is 180 subtract 53, which is going to give us gives us a 6, 127? 127 degrees. So we have two possibilities. So think of it kind of like this. You could either have a triangle where we have this side, and then this side here could either be like this. It's 53 degrees. Okay, I'm going to use those same measurements even though they aren't correct for this. We said that this original one was, let me go back up to the 26 and 34.
Yeah.
Yeah, it definitely wouldn't have worked. This should have been like, let's say this one was 34 and this was 26. This will make a little more. Oh, actually, no. Let me say 26, 34. Let's use the original ones. Let's say that's 26 and 30. And again, they're not the correct numbers, right? This could be 53, or we could have a triangle like this, where this is 127 degrees, and this is 26 and 34. Okay, and that kind of changes the rest of the angles within this. Okay, so it just kind of depends on which of these two scenarios you're in. So each time, once you get this angle, you need to then calculate two scenarios. One where this is an acute angle, one where this is an obtuse angle, and then you use the rest of the information to find out the remaining angles on the side.
Only angles? You don't really need to find the other
there's
side.
technically another side. It depends if the question asks you that or not.
Yeah, it just asks state the number of possible triangles.
Oh, okay. So
that's
two.
0.
Oh, this
right?
one would be 0, yeah, because it was impossible.
Yeah.
The example where I kind of did 0.8, then there would be 2.
There would be 2.
And then, again, remember in this one, at this point, you've actually already been given another angle. Let's just call it theta. Because in order to solve this part, you technically had another angle.
Yeah.
So it's actually pretty simple from here. From here, we just add these two together and subtract from 180. That will give us this one, which leaves us with only one unknown side left. So once you get to this point,
yeah, then you just use
subtract
Sine
from
Law.
180. You don't even need sine law for the other angle. You can just subtract from 180 because you already had one technically.
Oh, no, I mean like for the,
and
for the other
last
side.
one,
And
sine law.
that's it.
Exactly.